Hi, I'm Michael Brand, and you're watching How to Lose Money on Analytics, a video tutorial series all about the pitfalls of advanced analytics, which we at Otsma Analytics aim to teach people about and help them avoid. You see, there is a big difference between the hype world of analytics, which we've all seen, we've all heard, so many of us are investing in, and the technical realities of what those words, those terms actually mean. And if you're not aware of these differences, what you will end up doing is ask the wrong questions of your analysts. And they, in turn, will do the wrong type of work and will get back to you with answers that are not just the wrong answers, but also will be misinterpreted. Now, of all the culprits of advanced analytics, none stand more out than the term predictive analytics. It has been used as a great buzzword, topping the hype cycle for many years now. But what does it actually mean? What is predictive analytics? And why, when you're asking for it, you are asking the wrong thing? So without further ado, predictive analytics and why it's not what you need. To explain the answer, you need to understand that predictive analytics is really analytics using predictive statistics. There are different types of statistics. We use them in different ways. I'll explain 4, which crop up in just about any type of data science. The first is descriptive statistics. Descriptive statistics is when you just count things. How many people are in the room? How many shirts are on the shelf? You can build summary statistics over these. They're still counting. So you can talk about what is the average height of a person in the room. What is the maximum? What is the minimum? These are all descriptive statistics, and if you've ever done any form of BI, that's exactly what BI is all about. More advanced than that is what we call inferential statistics. Inferential statistics are very similar quite often in how they are computed to descriptive statistics, but have very different meanings. Inferential statistics is when we know that what we have in front of us, those people in the room, they are a sample. They are a sample of a larger population, and hopefully a representative sample of that population. And we might want to know things about that larger population. What is the average height of a person in that population? What is the maximum height of that person? What is the minimum height of a person in that population, etc. Now, these inferential statistics should not be confused with descriptive statistics. When we calculate the mean of a population, we sometimes take the average of our sample, but the interpretation is very different. The meaning of a mean, well, the mean we don't know. We can estimate it, we can give confidence intervals for it, but we can't actually know it. We're estimating it by the average. Sometimes estimating is very different, even for the same type of statistic. The maximum of the population and the maximum of our sample are not the same thing, and we will be using very different computations to get to each. Which brings us to predictive statistics. A predictive statistic is one that completes for us unknowns. Sometimes these unknowns are because they relate to future events. Sometimes they are unknowns for other reasons. For example, a recommender system. If I am recommended by Amazon something to buy, or I'm recommended by Netflix something to watch, these recommendations are not based on how much I like that particular item. They are based on how much the system thinks I am going to like it, based on other people, based on other products, my past behavior, the past behavior of other people who have bought the same item, etc. That is what predictive analytics is, and we have a lot of machine learning tools in order to do it better and better. Basically what they do is they learn by example. We give them the data that we have, and we extrapolate into areas that we don't know. So that's predictive analytics. Why is it not the thing that you need? Well, let me get to the fourth type of statistic. Prescriptive statistics. Prescriptive statistics are answers to the question of what should I do? And in a business scenario, that is really the only question I have ever been asked. What is the right thing to do at this point? Now, sometimes, as was the case with descriptive and inferential statistics, the answers can be quite similar. The answer to how many shirts should I put tomorrow on the shelf is very closely related to how many people are going to buy shirts tomorrow. Perhaps the optimum will be different in both cases because what I will perceive as a business loss will be different. Getting too many shirts on the shelf may be associated with just some waste of ordering shirts, but having not enough shirts on the shelf may lead to dissatisfied customers, which will cost me a lot more. So maybe I want to err on the side of caution. But other than those very small differences, it doesn't seem like there's a major difference between predictive and prescriptive. Well, there is. One way to see why there is to look at where these analytics lead us in terms of conclusions. I'll give you a simple example. Supposing I want to find out what makes a good salesperson, and I can correlate all of my sales data with all of my HR data in order to understand what properties that I see in the person are reflected in higher sale values. And maybe in doing so, I find that there's a very strong correlation. The highest performing salespeople are the ones who spend their vacations in the French Riviera. In terms of predictive analytics, that is a great find. It tells me that if I see a well-performing agent, a well-performing salesperson, that person is very likely to spend their vacation in the Riviera. Conversely, if I see a salesperson spending their time in the Riviera, they may be very likely to be a high-performing salesperson. What it does not reflect at all, however, is what should I do? Because if one takes these statistics and thinks that they are causal, for example, that I can up my sales by sending some of my salespeople to the Riviera, that will not work. The correlation that was so evident before will at that point break. It will break because it's not causal. Prescriptive statistics are based on a causal understanding of the underlying reality. So why is predictive analytics enjoying the hype that it does? Well, the basic answer is that it is simply easier to do than prescriptive analytics. Specifically, it is more standardized. It is easier to toolify. It is easier to sell as an off-the-shelf product, which is why vendors have been much quicker to productize it and then much quicker to begin a big marketing message that this is what you should be using. However, in terms of the actual technicalities of it, those tools do not deliver the answers that you want. Have you fallen for the predictive analytics trap? Tell us your story in the comments below. At Otsma Analytics, we provide analytics consulting, analytics training, and even analytics auditing, so you can get external validation for your models and for your methodologies in order to ensure that you do not fall into this or any other pitfall of advanced analytics. Until next time, happy data modeling, and don't get duped by lies, damn lies, and statistics.